In this video, we'll continue to look at vertical asymptotes and holes in the graph. For this example, I'm going to need to do some factoring. In the numerator, I can see 4, so let's go ahead and factor a 4 out of this one. And in the denominator, I'll need to factor by grouping. So in the first two terms, I can factor out an x cubed. And in the second two terms, since this term is negative, I'll need to factor out a negative 9x. So I'll be left with x in this term, and then negative 2 in the second. In the numerator, my 4 is still out in front. I have a trinomial that I can factor. I have x in both terms, and I need two numbers that multiply to give me a negative 6 and add to give me a positive 1. So I'll need a positive 3 and a negative 2 for this one. Here I can see my x minus 2 binomial in both of these terms. So let me factor that out. And what I'm left with then is x cubed minus 9x. I'll need to factor an x out of that one. And then I have a difference of squares here, so let me go ahead and get that factored. Alright, now I'm ready to determine asymptotes and holes in the graph. Notice that this factor of x plus 3 is in both the numerator and the denominator. So it will cancel off, but I need to indicate that that's a problem in the original function, and it'll be a hole in the graph rather than an asymptote. So we have a hole x would have to be a negative 3 in order to make this a 0 and to give a division by 0. So x equal negative 3. And then I also have this factor, x minus 2, is in both the numerator and denominator. So those will cancel off, but they would cause a problem in the original function. And that would be at x equal positive 2. Right. The other two factors, x and x minus 3, those will be asymptotes because they are not removable. So this one would be at x equals 0, and this one would be at x equal positive 3. For this one, I'm going to multiply top and bottom by 2 to get this fraction off of there so I can look at it a little bit better. So if I multiply the numerator and denominator by 2, the top just becomes x cubed, minus 2x squared minus 8x, and the bottom becomes 6x squared minus 12x minus 48. All right. Let's pull an x out of the top, and I'll be left with x squared minus 2x minus 8. And then in the bottom, let's factor out a 6, and I'll have x squared minus 2x minus 8. Now at this point you would be tempted to cancel these off, but we need to go ahead and continue to factor so that we can find the holes, since these would cancel off. So in my numerator I have x, and x in the first terms, I need two numbers multiply to give me a negative 8 and add to give me negative 2. So I have a negative 4 and a positive 2. And that'll be factors in the denominator as well. Plus 2. All right, so these do cancel. But since they would initially cause problems in the original function, there will be holes in the graph. At x equal a positive 4 would cause a 0 here, and negative 2 would cause a 0. Now for this one, we want to determine the vertical asymptotes. We know that secant is the reciprocal of cosine. So I'm going to look at the graph. Cosine graph looks like this. And my end of my graph of one period here is 2 pi. And at this point, that's pi. So my secant has asymptotes wherever my cosine crosses the axis. So my secant graph, now not this graph, this is just the standard secant graph. Right. So I would have asymptotes on the standard secant graph at pi over 2 and at 3 pi over 2. But for this one, I need to basically look at this argument. So I'm going to have vertical asymptotes at pi x equal pi over 2 and 3 pi over 2. And so on. This is a periodic function, so it goes on forever. Now if I solve for x, we're going to divide both sides of the equation. First of all, taking just pi x equal pi over 2. So we'll divide both sides of this equation by pi, and we see that x then is equal to 1/2. And also, when I divide both sides here by pi, I have 3/2. And this will continue, actually it continues to the left and to the right. So we can see that we're multiplying 1/2 times 1, 3, 5, and so on. So I can state then that I have vertical asymptotes at x equal 1/2. And then to indicate an odd number, I need 2n plus 1, where n is an element of the set of integers. Now this would be one way to show that, or we could multiply through our 1/2 and state that x is equal to n plus 1/2, where n is an element of the set of integers. Or we could get a common denominator and state that 2n plus 1 over 2, where n is an element of the set of integers. All of these are just fine. This is a 2.